Okay, so today we're going to have a deep dive into declarative schema migrations. And just to set context, so in the past decade, the trend in managing resources in the cloud has been towards a declarative paradigm. So tools like Kubernetes and Terraform brought us what we call infrastructure as code, which means that as engineers, we can define the desired state of the system and use a tool to configure it for us. This, of course, has lots of advantages, and it's gained a lot of ground in the industry. But 4 years ago, when Ariel and I started the company, one of the things that bothered us that this paradigm didn't really trickle down into database schema management. And we saw this gap between infrastructure as code and database schema management, which kind of drove us to build Atlas. So Atlas is 3 and something years old. We open sourced it in 21, almost 6,000 stargazers on GitHub, over 80 contributors, and over 3,500 GitHub repos publicly using Atlas. So it's safe to say we've gained quite some ground in the industry since we started. And Atlas has 2 kinds of workflows that probably the big majority of people here are probably using our version migrations workflow, which is similar to classic migration tools, with the difference that migrations are automatically planned based on schema as code. And we have the declarative workflow, in which you define your schema as code, and Atlas plans the migrations and applies them for you without the intermediate representation as a migration directory, a linear history. So when we first launched Atlas, a lot of people were interested, and many or most of them told us that it wouldn't work and that we shouldn't. It's a waste of our time. And I'll show some of the comments from Hacker News, the most friendly site on the internet. If you ever build technology, you should definitely publish it there to get enthusiastic about what you're doing. And having interviewed, I think, over 100 engineering teams and exploring this idea of declarative migration in production, we tried to distill the objections, the concerns, and we came up with 3 different things that we think are why people won't use or don't use or haven't used declarative migration in production. But it might surprise you or not. I know the age variance in this meetup webinar is pretty large, so some of you will be surprised by what I'm about to say, and some will know this. But actually, declarative schema migrations are not a new concept, not something we made up with Atlas. It was in a previous incarnation something called state-based migrations, but it was always considered to be kind of a toy or a dev tool, but not something that you could seriously use in production. For example, the Hibernate docs. Hibernate has something called HBM to DDL, so it's for testing and prototyping. Entity Framework Core says ensure created, which is the method used to provision schemas. It will only work if your database is empty, so not something you can use seriously in production. Liquidbase says state-based deployments are unreliable and risky. So kind of from the experts, people who worked on this problem all seem to agree that it's a bad idea to do declarative schema migrations. And having analyzed the problem, we came up with 3 challenges that we think if we want to solve this, we need to overcome. So the first one is review and approval flows. So obviously, for technical reason, migration files are there for machines, right? This is the instructions to the computer, what SQL commands to run against your database when you're upgrading a version. But if you look at engineering as a socio-technical thing, there's humans and computers. You will see that they're also there for the humans in the system, which for the vast majority of teams that we interviewed, reviewing migrations in the pull request phase is the main quality control mechanism for preventing bad stuff from happening to the database. So the idea there is a file that is presented to the team for review during code review is critical for ensuring that we don't mess our database up. So with state-based or with declarative migrations, basically we remove the migration files, but what do we put in their place? Because we still want people still want to have an idea of what's going to happen. So we need some alternative mechanism to provide this clarity. The second one is safety checks. So migrations, if you're attending and you're interested in Atlas, you probably know that migrations are a risky business. If you're not careful, you can easily nuke your database in multiple ways, from accidentally dropping resources, to locking your table for a long period of time, to causing a breaking change, breaking the contract between your backend and your database schema. So plenty of things, plenty of ways to shoot yourself in the foot. And the main concern that is raised when people think about state-based or declarative schema migrations is, can we trust a machine to do a safe job, to not mess up our database? And if you really think about it, this is really a scary idea. And in the Hacker News discussion that I told you, one of the commenters wrote us something that I think influenced us in a very deep way, which is, I'll never be comfortable with any tool that automatically generates schema changes, as I'm just never sure at what point it decides to delete parts of my production database. So big safety concern around declarative schema migrations. Number 3 is the need for customization. So one of the ways that I can, in my mind, visualize the migration planning problem is to think about it as something similar to navigation. We want to get from the current state to some desired state. And just like with real navigation, navigating with your Google Maps or whatever, there are often multiple routes, multiple ways to get from point A to point B. And some of these routes might be completely dangerous and undesirable for you. For example, a simple column rename can be achieved either by doing an alter table and renaming the column, or by dropping the column and recreating it. Now, the end schema is the same in both cases, but in one of them, you keep your job, and in the other one, you're not sure what's going to happen. So when you think about this as a navigation problem, you say, how can we let the user control the decisions that Atlas makes as a tool in order to prevent the unwanted routes, or to prune the unwanted routes away from the planning phase? And this is made more concerning by the fact that tools like Terraform and Kubernetes don't allow users to customize the plan. When you kubectl apply your manifest, your application, you don't have any say about what the order of operations is going to be. You just let the controllers on your cluster reconcile between the current and the desired state. So the question is this acceptable for schema changes? And based on our product and industry research, it's not acceptable. It's something that even theoretically, if it is possible, it's not acceptable from a culture and expectation perspective. People want to have control when they need it. So with that, we explore what does it take to provide you with production-grade declarative schema migrations. And now I'm going into our recent releases from Atlas. So we've had declarative migrations for a while, but we provided the advice to many teams that under this and that considerations, they should probably stick to version migration with automatic planning. So get most of the benefits of declarative migrations, but still use version migrations. And with recent releases, we believe that this is no longer the case, or that it's trending towards not being the case. So let's see some of the recent changes to Atlas and how we can solve or address some of these challenges and concerns that people have around declarative migrations. So the first one is to be able to pre-plan, right? As users of declarative migrations, we want to see stuff in advance, so we need some pre-planning mechanism. So we added to Atlas a command called Schema Plan. So when you run something like Schema Plan, Atlas will calculate the plan. It will run some analysis to check that it's safe and give you some warning if it's not, and prompt you to accept or not the plan. Okay, this, if you accept the plan, Atlas will create a plan file, which is basically made of three important parts. The first is the from hash. This is sort of a fingerprint hash that represents the schema at the current schema as Atlas sees it, and we use the same, call it hash function, to calculate the desired state. So we have a tuple describing exactly or in a deterministic way that this plan is a plan to make some specific transition from specific state A to specific state B. And the plan, of course, contains the SQL, the statements that we want to run against the database. When the time comes to apply the plan, we can do Atlas schema apply and provide a specific plan file. Okay, this allows us to do a deterministic declarative migration because Atlas will still inspect the current desired state. It will make sure that the provided plan is from and to the correct hashes, and if everything matches, it will apply the plan. Okay, so it gives us this determinism that we know that the plan that we had in the past matches our current state and can be applied to the database. A second mechanism that you might have, it's I think been out for almost 2 years, but is also relevant for this concern, is diff policies. So with diff policies, you can define on the project configuration different rules or policies that govern the way that Atlas plans changes. So with Postgres QL, famously, index creation is a locking operation, which on a large table is a problem. You don't want the database to acquire a lock while it's constructing the index on disk. But Postgres provides us with the modifier concurrently, so we can tell it to create the index in the background, which has some implications. But in many cases, this is what teams prefer. This is the best practice, and the team will enforce this during code reviews. So what we can tell Atlas with this diff policy is always create and drop index concurrently. Similarly, you can provide a skip policy and tell Atlas to omit certain operations from the plan. So let's say if we drop the resource, we can tell Atlas effectively to ignore this until at some later point in time, we want to kind of prune or vacuum all of these unused columns, as many teams do. The final aspect of customization is to create custom plans. Sometimes the policies are not granular enough, and we want to change something for a specific change, in which case we should use this command that I'm going to show you. Yep. So Atlas schema plan, and I'm using the -- edit flag. Now my default editor opens, and I can, for example, seed the table with some record. Okay, now Atlas recognizes this, now that the insert statement is part of the plan, and I can save it, and it will now be part of my plan file that I can later execute. So I have an opportunity to modify the schema to customize it in the way that I want it. But you might be thinking, what if I modify the schema in such a way that the resulting schema is no longer my desire? I essentially introduce some drift by changing the schema. So Atlas has a mechanism to help us prevent this scenario. So suppose I'm doing the same operation. I am editing the plan manually, but now I'm adding a column that was not there in my desired state, in my T1 table described in the top of the screen. Atlas will detect this and tell me, abort, the plan state does not match the desired state. And this is the diff between the two states. So essentially, it allows me to edit the transition, to edit the migration plan, but I still must, but Atlas guarantees that the desired, the resulting schema is still the desired state. Yeah. Another concern that people had, as we mentioned, is safety checks. How do we know that the changes that Atlas proposes are not going to break our database? So for this, we have had for version migrations for a long time the migrate lint command, which for version migrations allows you to take a specific change set and run some analyzers against it. So detect stuff like destructive changes, breaking changes, table locks, all sorts of stuff. Could have been done using version migrations up until now. And what we added with the recent release is to integrate this into the declarative migration flow. So if I run Atlas schema apply now on a local database, you see that the schema is already provisioned. Suppose I want to drop this table, so I delete it from my schema file. After trying to apply the schema, you will see that Atlas plans the change with the drop table, but it also supplies an analysis telling me that dropping the table is a destructive change and gives me some suggestion what I should do before dropping it. So we now have safety checks integrated into declarative migrations. Okay, so we demoed some or showed some of the ways that we address these challenges, but we showed it kind of on a limited and local scope, something that would run from my file system. But in practice, most of you are probably running migrations from a CI/CD pipeline, not directly from the computer. At least I hope that's what your team is doing. So let's think how such a pipeline would look like. And I think we care about 5 things. One is that we want that all changes to the database result from changes to the desired schema. So the way we drive changes by changing the desired state, not by adding migrations. Changes are planned automatically during the CI process. So as a developer, all I do is change the desired state and I get the plan back from the system. Changes are analyzed automatically to detect potential issues. If I propose some change that has negative impact, many of the developers on our team don't have a lot of database education. They're not aware of many risks. So it's our system's responsibility to inform of the risk, and Atlas should be able to give us that. Changes should be approved by the team before being applied to the database. And finally, changes that are applied to the database in a deterministic and safe manner. Okay, so we want this hermeticity, this guarantee that whatever we saw in CI is going to happen in CD. Okay, and I'm going to show a short example. Let me switch to my GitHub tab. Okay, so I have here an example. Let's see if I can open it with an editor. Much nicer. If you didn't know, if you press dot in GitHub, you get like a local VS Code. That's pretty cool. So I have here a project, and what I'm doing here is I have a composite schema. So this is an application that has some Python code, and some of the schema is defined in SQL. So we have this schema file that defines the some portion of the schema, but the other part is a SQL Alchemy model. And what I'm doing with what I'm doing with Atlas is that I'm stitching them together into one representation. So I have my composite schema that contains both the SQL Alchemy model and the SQL file. And the way that I drive change is that I'm going to make a pull request that changes this this model. So I'm going to make some change to the Python code and simultaneously a change to my SQL representation. And just to save time, because the actions can take a couple of minutes to run sometimes, so I already have a pre-existing pull request. So you will see that my pull request basically contains a one-line addition to the Python model, another addition to the SQL model, and what Atlas does during once the pull request is created is it creates this comment. Now the comment contains three important things. One is the plan. Okay, so this is the specific plan that Atlas planned for migrating the database to my new state. It contains the linting analysis. So for example, here's a safety check. Data dependent change detected. Adding a non-nullable column will fail in case the user account table is not empty. And there's instructions what to do if I need to manually edit the plan. Okay, so suppose I want to seed some data, or I want to do this migration in some way that will alleviate this concern. Okay, so you can also see this in Atlas Cloud in the schema registry. The plans exist in the registry initially in pending state. And once we merge the pull request, you'll see that it becomes in an approved state. Okay, so we also have this mechanism for differentiating between plans that were just there on a pull request level, but were never approved by the team, and therefore should not be applied to our target database, and stuff that already made its way through the pipeline and is ready to be applied. So once, I think we can go back to our slides and talk about this a bit more. So I showed you something that is something new that we introduced with Atlas, and it's called the schema registry. And I know some of you, I recognize a lot of the people in the call. I know that a lot of you are using this, but not everyone is aware of it. So I thought it's a good idea to spend a few minutes to talk about why schema registry is important and why it's useful. So schema registries are essentially containers that store schemas and plans. So every time we change our schema, we merge it to master, we update the schema, the desired state of the project. And plans, as you saw in the UI, are transitions. They are the migrations. They're no longer ordered in a linear history like with version migrations, but they are tuples of from this schema to this schema. This is the set of instructions that you should run. You should think about it sort of like a Docker hub or an artifact repository, but for schema migrations, purpose-built for schema migrations. And as you saw in the demo that I showed, or the slide that I showed before, it's definitely possible to use simple files, right? You can create Atlas schema plan --save, and you have a file, and you can apply it later. So you don't need a cloud layer in order to do pre-planning. But why do we think that it's useful and beneficial to your project to use something like schema registry? So for three reasons. Number one is it acts like a source of truth. So similar to the fact that when we create a version of our application, we create some build artifact, a Docker image or a Java jar or something like that. We push it to some Artifactory, we want some way to make sure that only code that went through the team CI/CD pipeline makes its way to production. Okay, so I wouldn't think of someone from my team, compiling the Go binary and directly throwing it away, throwing it to production on Kubernetes. It just doesn't work that way. It has to go through an artifact repository. So in the same way, we think of migrations and schemas as production artifacts, as build artifacts that are later deployed. So the goal of the schema registry is to act as this intermediate layer between the build system and the CI system and the production system. The second advantage is that it streamlines the deployment. Okay, think about it that if you have a bunch of branches going around, multiple developers working at the same time, even if you have some directory with plans in your GitHub repository, when it comes time to do schema apply, you're going to need some layer that figures out which plan is supposed to run now. So it needs to do the matching between the current desired and the desired state, and to look if there is a relevant plan in the schema registry. So using the registry, Atlas can find the approved plan automatically. So it serves as kind of a, if we use the navigation metaphor, so the registry would be this GPS satellite that gives the vehicle information about which paths are allowed, or the mapping data that tells you where you have traffic and traffic jams. And the third advantage is, as we said, it's a schema-aware artifact repository, so it can do things like ERD, time travel, documentation, and just as a container that contains this valuable information, can give your team access and visibility into this information. You can think about it similar to how Docker repositories over time start to give you things like security and dependencies and metadata. In the same way, if you push your schemas and your plans into a schema registry, we can extract the metadata from there and give your team more value and things that are useful around schema management. So what happens? We saw the whole road until we go to the schema registry, right? We create the pull request, we approved it, it was pushed into the schema registry. Well, what happens when we do schema apply? What happens during deployment? So first, Atlas inspects the target database. This is the current state. Atlas calculates a fingerprint hash, as we call it. This is this long hash that represents the current state of the database. Then Atlas analyzes the desired state. Okay, this is where we want to get to, and assigns a hash to that. Now we have a tuple from hash to hash. Atlas uses this tuple to search the schema registry for a matching migration plan. If a plan is found, Atlas verifies that it is approved. As we say, plans can exist in the registry in a pending state that is not deployable. Atlas verifies that the plan is approved, and if everything is okay, it moves forward with executing the migrations on the database. If you think about it, many outages that we've written a bit about and talked a bit about in the industry in recent years are a result of developers running schema migrations directly from their computer on the wrong environment, for example. So having this coordinating layer and requiring that the plan is approved, meaning it went through the whole CI/CD pipeline, can give you a bit more peace of mind that only the right plans are allowed to be executed in the system. But what happens if there is no plan? If the registry doesn't contain a plan? This can happen because there is no CI/CD pipeline, the CI/CD pipeline did not run, or because there is some drift. Someone changed the database in a slight way, and now we don't have a plan from X to Y. We have some X tag, and it's a bit different, so the hash is different. So what happens when we don't have a plan? So by default, when we're doing CD, meaning we're not in interactive mode, if you're running it from your computer, you can get a prompt, and Atlas will ask you what to do. But when we're talking about the CD pipeline, By default, Atlas will not deploy if we don't have an approved plan. Okay, so I don't know what to do, raise my hands and exit. But in some cases, this is actually undesirable. It's the safe choice, right? Do nothing is usually a safe choice. But in some cases, you actually want Atlas to be able to make progress. For example, if you are working locally, you want to override some changes, you're playing around with the database, or you're working in a lower environment that needs to be reset to some version, and you know, or you're rolling back an environment. So in many cases, the advantage of declarative resource management is that you have this versatility. You don't have to pre-plan everything. You can just schema apply or Terraform apply and eventually get to where you want. So in some cases, you actually want this flexibility. So what's our solution to that? We don't want a super rigid system that to make some change, you always have to jump through all the hoops. So what can we do? If no plan is found, Atlas calculates a plan. This is, you know, just a read-only operation. It reads the information schema, or it knows the information schema, it knows the desired state, and it will calculate the plan ad hoc at runtime. The plan is analyzed using the same migration analyzers to check for destructive changes, for breaking changes, etc. And then what happens next depends on what we call a review policy. So essentially, you can, in your lint block, in your configuration, you can define 3 levels of review policy. Error means that it should only ask for review if a high severity error or something like a destructive change, for example, is found in the plan. Warning means we should ask for review, for a human review, only if some diagnostic is found. Doesn't matter the severity. And always says you should always ask for review. So essentially what we created was this way for you to say, you can think about it sort of like autonomous vehicles. And autonomous vehicles can drive today in fair weather conditions fairly well. But at some point, if the weather is bad or the conditions on the road are unexpected, at some threshold, some confidence level, the car tells you, listen, you need to drive. I'm not making the decisions. I don't have enough confidence in what my model is outputting, and now I need a human in the loop. So in the same way, you can define Atlas's sensitivity to say, okay, only like really severe stuff, stop and wait for review. And if it's, you know, just a warning or stuff that's not going to be very meaningful, then you can go forward with the change. Yeah. So missing a bullet here, but just to summarize what we did. So we talked about the fact that until recently, our industry was pretty much in consensus that declarative schema migrations are not production-grade tool. They are dev, local staging, prototyping mechanism, but due to different considerations, not fit for production. We went and analyzed why. What were the top concerns in our industry around reviewability, around safety, around customization, and we show why. And to date, most people rejected the idea of declarative schema migration. And finally, we showed how the different new components that we added to declarative schema migration, hopefully, you will be the judge on this, of course, as engineers in our industry, are able to address these concerns and these risks using different mechanisms. So we saw how we have pre-planning, so we have a chance to review, we have a way to guarantee that only plans that we know about will run. We show how we can integrate safety checks to add some automation and guardrails to prevent risky stuff from happening. And we talked about the schema registry, this coordination layer that allows us to integrate all of this into one workflow in a modern CI/CD pipeline.